Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 31 in our incredible new tutorial series where you're learning how to think like an engineer using the Arduino Uno R4 Wi-Fi. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee, poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Sunfounder Elite Explorer Kit. Now, hopefully most of you guys already have your gear, but if you don't, look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to teach you today. And what I'm going to teach you is I'm going to teach you how to measure temperature and humidity using the Arduino R4 Wi-Fi in one of the sensors that is in the kit. So what I'm going to need you to do is get your kit, and I'm going to need you to open it up, and then I need you to find your little goodie bag. Okay, so my little goodie bag is up here on the top, over on the side, and it is this little bag of marvelous, wonderful, spectacular electronic goodness. So I need you to get this, and what we need to do is we need to find the DHT11 temperature sensor. And you can see if you look on the card, it's got all the components, and this shows you what it looks like. So you're looking for that little blue sensor with the 4 legs on it. Now you also notice that as I teach a class, as I teach one of the components, I mark that component off the list, reminding me that I have already taught on a particular component. So whose day is it today? It is the day of the DHT11. So I'm going to get my little bag, open it up, and look what I find. This bad boy right here. So you find yours, and then put your goodie bag back in the box. Now you try to close the lid on the box. Yes, I know it's impossible, but if you really mash and deform the box and clip that thing, you will get a bulging closed box, because we all know it's impossible to ever get the components back in the kit once you open it. Okay, so we've got this little component. We're going to come over here, and I have a new view for you guys, I do believe, and it's going to be this one right here. I'll get out of your way. I'm going to get further out of your way today. And so far, what I've been doing on my builds, just been taking you through it step by step, showing you every connection. But what we really want to get to is we want to get to the point that I don't have to build the circuit for you wire by wire, explaining every single connection. I want you to start getting comfortable building the circuit yourself based on a schematic. So you see I have a schematic up here, and that schematic shows you how to connect it up. So as we're moving forward in the future, I want you to get comfortable building your own circuits from schematics. But today I'll do both. I'll have the schematic, and I will be taking you through the build step by step. So I'm going to take my sensor, and I'm going to come over here, and I'm just going to plug it into a convenient spot. That looks like a good spot. Now I'm going to look at the schematic, and I see the left leg of the DHT11 that goes to 5 volts. The left leg of the DHT11 goes to 5 volts on the Arduino. So I'm going to put my wire there. Okay, so that is the left leg, and then I am going to come over to 5 volts like that. Okay, and try to keep that wire out of the way. Now the second leg, leg number 2, is going to go to pin 11. So leg number 2 is where we're actually going to make the measurement from. And so that leg number 2, the second one, is going to come over to pin 11 on the Arduino. So far so good. Now what you see is pin 3 is not hooked to anything, so we skip pin 3, and then we go to the 4th pin, which is the rightmost pin, and we take that to GND or ground, like that. Okay, so that is all hooked up. That was pretty painless, wasn't it? So as we start moving forward, I want to get to the point that I just point you at the schematic and you go build it, and then I'll take you step by step through the explanation and through the code, if that makes sense. So now we're going to come over to our code view here, and we're going to jump in and we're going to see if we can program this thing up. Well, now what I will say is for this sensor, we have to load a library. Now you only have to go install the library the first time, then it'll always be there. Okay, but the first time you've got to go install it. So we're going to come to this little icon with the books, and then what do we want to install? We want to install DHT11, and then you're going to have a whole bunch of them that are going to pop up here, and we want maybe what I should say is we should search on DHT, because you want to make sure that you install the same library that I do. I don't like being that small. Okay, so if we type in DHT, we're going to scroll down, and I want you to find DHT sensor library. Okay, now I want you to see there's a lot of different versions, but I am going to be using version 1.4.6. Now you might take this class 2 years from now, and the most recent one for you might be 2.7.14, but you should use the same one I'm using. And that way you'll be sure you get the same results I do, because I don't know what they're going to do in the future, and a future version of this might not be exactly the same. So usually the smartest thing is to use the exact same one that I am. So now I'm going to say install, and it says install all or install without dependencies. So this library is going to call other libraries, specifically the Adafruit Unified Sensor Library. I want to install all, because otherwise you're going to be missing things and you're going to be getting errors. So we're going to install all. So we have installed the library and we have installed the dependencies, and that is good. Now we come over, now that the library is installed, we can include it, we can load it. So I'm going to load it with the pound, and then include like that. And then what are we going to include? Open bracket DHT and then .h, like that. Okay, remember on our includes, that's one of the few commands that we don't put a semicolon at the end. All right, I'm going to just run it. I'm just going to run it just to make sure that it sees the library and it loads it, that I don't, if there's an error, there's a problem, I want to get it now. Okay, but it's looking good. That's going to work. Now what we've got to do is we have to define some parameters. So I want to define, and this is kind of like putting a value in a variable. I want to define my DHT pin, and that was what? 11. Now you notice you don't use an equal sign. You just say, I've defined DHT pin to be 11. Now I'm also going to define is sort of like making a constant. DHT pin is 11. It's always going to be 11. So it's kind of like a variable that doesn't change, and we're going to call that a constant. We also have to define DHT type, DHT type, DHT-TYPE, and that is going to be DHT11. Now, what is that about? Well, there's two different types of DHT, at least two different types of DHT sensors. There's the DHT11, which we have, and the DHT22. Now, the DHT11 is inexpensive, and it's a good component to learn on, and one of these days it'll wear out or it'll break or something like that. The DHT22 is a much more robust sensor. If you were really going to use this in an application, you would probably want to use the better sensor, but we use the cheap one to learn on, if that makes sense. Okay, so now we've defined the type, and now we have to create our sensor object. Well, what are we going to call our sensor object? I'm just going to call mine, DHT. Now you could call yours whatever you want, but I'm calling mine DHT, okay? And then whenever I talk to DHT, I will be talking to my sensor. And how do I create that object? I create it with the method DHT. That you have to do exactly like I did it. And then I've got to tell it what pin. Well, it's DHT PIN, which we just defined, and DHT TYPE, which we just defined. So DHT pin is defined, DHT type is defined, and now I have a sensor object, and that sensor object is DHT. Okay, so now we're going to have to set up some variables. So I'm just going to say int. I'm going to set up my baud rate. BR is equal to 115 to 100. And then I'm going to put in a couple of delays. I'm going to put in a set up delay, and that's going to be equal to 1,000 milliseconds. And then int mesh delay, measurement delay, mesh delay is going to be equal to 1,000. Well, you might say, well, if they're the same thing, why don't you use one variable? But they're for two different purposes. These DHT11s can send back bad data or can send back an error. And what seems to happen if you try to read it too quickly after you have set it up, or if you tried to read it too quickly in the loop, you can get it to get confused and start sending out errors. And so one of the things when you're using these DHT11s, don't try to hammer them too hard. When I set it up, when I start the sensor, I'm going to put a setup delay, and then every time through the loop, I'm going to put in a measurement delay. And we might start playing with it and get an error. We might find out that we need to adjust those two delays. So that's why I am using two different ones. Okay, well, let's just see. I'm going to now set up some variables for the things we can measure. Let's just look and say I'm going to set up a variable temp C for the temperature in centigrade, if that makes sense. And we're going to come back and do more and more, but I want us to try to kind of get to our first measurement as quickly as we can. And so I'm going to come here, and then I'm going to come in and I'm going to do a serial.begin at our baud rate, BR. That's good. Now I need to do a DHT, okay, a DHT begin. I might have lied to you a while ago. I'm afraid that I might have lied to you. Okay, DHT dot begin, like that, okay? And then after I do that, what do I want to do? I want to put a delay of the set up delay. Okay, like that. Now let's just run in and make sure we don't get errors. And then I'm going to show you something I don't like. What do it define? You don't put a semicolon on defines, just like you don't put them on a load. So let's try that again. Okay, I think it's going to work this time. Very good. Now this is I'm going to just see, I'm trying to think, is this the object we create and this is the method? Let me just see if I call this, because I'm interacting with it as little DHT. This is a little bit of confusing, but what if I call this my DHT? Let's see if I get an error if I do that. Yes, I do. Okay. But now let's see if I do this down here as my DHT. Now let's see if it's going to work. Yeah, I think I told you better. I think I told you wrong the first time. And this is the mistake I made. I used DHT and DHT. well, what is the object that I'm creating and what is the method? This is the method I'm calling the DHT library. Now I'm going to create an object that I call my DHT. So this you can name whatever you want, but this is calling the library. Okay, so we're going to call it my DHT. Okay, we're going to call the object my DHT. Sorry for that confusion, but it was bad that when I set it up, I went DHT and DHT. I like to call the thing that I define like my DHT, so it's just a reminder of that is my object. Okay, and then I come down here and I do a my DHT begin. Okay, now let's come down, and then we have a delay to give the thing time to actually get started. Now what we're going to do is we're going to come down to, I've got the void setup done. Now we're going to come down to the void loop, and just so I don't forget the last line of the void loop, I want to put another delay in, and this time it's going to be the measurement delay. And sometimes I get so excited as I'm coding, I forget to do something important like that. So that'll be the last line of the void loop. Now what I want to do is I want to see, can I measure, and what variable did I set up already? Temp C. So let's see if I can measure temp C. And how do I do that? That is going to be equal to my object, my DHT, and then dot read temperature. Okay, and then what I need to do is I need to set this to false. Okay, now that sounds kind of strange. What that means is the parameter that goes inside of this, do you want to read Fahrenheit? And if you put false, it's not going to read Fahrenheit, it's going to read what? Temperature C. A little bit of backwards thinking there, the way we started this, all right? And then what I'm going to do is I'm going to do a serial.println, and what I'm going to print is temp C, like that. And then I'm going to wait a second between measurements. Okay, is that everything that I need? I think it is. I think it is. Okay, let's run this thing and let's see what happens. No errors, and it is downloading. And we're going to go ahead and see if we can start our serial monitor here. And there it is. Boom, 28 degrees C. We're measuring temperature. Ladies and gentlemen, we are measuring temperature. So that is really great. Now, what's the thing that we don't like so much about this? We don't like so much about this is it's just printing 28. We need to print it a little bit better. And so I'm going to add here a serial.print. And what am I going to print? I am going to print temperature, like temp, like that, with a colon and a space. And then I'm going to print temp C. But I'm not going to go to the next line. I'm just going to print like that. And then I'm going to put serial.println. And what am I going to print ln? I'm going to print the string degree. I'll put a space degrees dot C. Like that, and then another space. And I'm putting those spaces in so it ends up nicely formatted when I print it, okay? So now let's see if this looks a little better. Let's run this thing again. What is that? What is that? Error. Serial print. Do you guys see my mistake? Who's your friend? Mr. Semicolon. But do you see how all this is saying define serial UR temp blah blah blah? You see how the lines are the error messages are kind of confusing. So sometimes you just got to really look carefully at your work. That was just a silly mistake, but I got a very strange error message. Okay, here it comes. Let's come over to our serial monitor. Look at that. Boom. Temp is 28 degrees C. Look at that. I like that a whole lot better. I don't like the period. I'm just going to put DEG, so I'm going to take that out. Okay, well, if I can measure the temperature in C. What else can I measure? I can measure the temperature in F. And so I'm going to come up here. I'm going to define a new variable, integer. Do I want that to be an integer? I think that's okay. That's okay. Yeah, that's going to be okay. Let's see what happens if we make it a float. Let's just see if it'll work. I don't know if it returns, but if you think it might be nice to know that you're at 79.5 degrees. So let's see if it'll work as a float. And if it doesn't, we'll come back and we'll put it back as an int. But it might be nice to get like a decimal, a decimal of accuracy here. So now we do temp F, and then we come down here, and as we measured temp C, this time we're going to measure temp F, and that's going to equal to my DHT dot read temperature. Now, how do I get it to read Fahrenheit? True, little T-R-U-E, like that. And that is going to measure the temperature in Fahrenheit. Okay. The other thing you could do is you could read it in centigrade, and then you could put an equation in and you could convert it. But now we need to come down and we need to add some more prints. And so again, this print ln is going to just be a print because I want to just keep going across the line. And then I'm going to say serial.print, and I'm going to print this time temp F like that. And then I'm going to do a serial.print ln. So we're going to go to the next line after this one. And this time it is going to be that space degree F. And I always put a space there, like that. Okay, so this is going to give us a little more information this time. So let's see what happens. Looking good, looking good. Come over to our serial monitor and look at that. Okay, the temperature is 28.5 because we used a float, 28.5 because we used a float. And in it's also 80, it's a very beautiful 83.3 degrees F. How cool is that? Do we stop there? No, we go on. We're going to power on because what else can we measure? We can measure humidity. So we're going to come up here, and who's your friend? The float. And we're going to measure HUM for humidity. We'll come down here, and humidity is going to be equal to, my friend, my DHT dot what? Read humidity, like that. Boom. And now after we've read it, what are we going to want to do? We are going to want to print it. So what we will do is we will keep on the same line. We'll keep on the same line. So I put print, not print ln. Now what I am going to do is a serial.print. And then what I'm going to print is humidity, like that, and a space. All right. Then I'm going to do a serial.print. And what am I going to print? The humidity, like that. And then I'm going to do a serial.print ln, because for now that's all we're going to print. And I'm going to print the string, and it is going to be a space and then a percentage, like that, and then like that. Now let's see what happens. This is kind of cool, isn't it? Man, we're cranking through this thing and not having a lot of trouble so far, huh? It's the coffee, right? The coffee is working. Okay, so then we come over here and let's get this out of the way. Boom! 28.5 degrees C, 83.3 degrees F, and humidity at a very moist 72%. 72% relative to humidity. Do we stop there? No, because there's something called the heat index. And if you have a very humid day and a very hot day, it feels hotter than if you have a hot day with a low humidity. So it's like there's another number, which is kind of like what it feels like, Okay, but what I've got to do is I got to tell you a little bit about the DHT11 before we do that. And the thing is, sometimes the DHT11 will get a bad read and it will return something called a NaN, N-A-N, and N-A-N means not a number. And usually you get N-A-N if you like try to divide by 0 and it's like, whoa, that's infinity. Whoop, infinity isn't a number. So if you ever see a result on the Arduino, N-A-N, not a number, it means somewhere probably you've divided by 0 or somehow you've gotten something really corrupt. And the problem is that if I do a calculation now below, and if one of those things I measured just happened to be a corrupt value in NaN, then the whole program crashes. And we don't want the whole program to crash. So we want to check before we go any further and make sure that we don't have any bad data. Because on a print, it will just print NaN. The program won't crash. But if you try to say 3 divided by temp, and temp is an NaN, then the whole thing can go bad pretty quickly. So I'm going to say if, and then this is NaN. So I'm checking for the condition, is NaN of what? Of temp C. So is temp C not a number? That is one condition. What would be the other problem? Or bar bar, which is the shift key above enter, is bar bar. That's or, is not a number. What's the other thing? Temp F. Okay. And then what's the other condition? Or what is not a number of what? Humidity. So what are we doing? We're checking to make sure, that we don't crash the program, that we don't have one of these bad numbers. Well, what do we do? What do we do in this case? So what I want you to see is I open the if clause, and this closes the if clause. What do I want to do? I'll print a warning serial.println, and what do I want to print? Failed to read data on DHT11, like that. Okay, now I printed that there's a problem, but if I go down and I do the rest of those calculations, what's going to happen? What's going to happen is it's going to go down to the next lines of code and crash. So what I want to do is I want to break out of it, and I do that by doing a return. So what that return does is if you get a bad reading, it will break out of the loop and it will go back and it will start the void loop again. Now it will show you, it'll print out and show you that you got a bad reading, but it doesn't crash, it tries again. And usually if you get a bad reading, maybe you'll get 1 or 2 and then it'll get back working again. So this just keeps your program from crashing, because this particular program, you might want to leave it running. You might want to just sit there and you might want to be reading temperature and humidity, okay? So hopefully that makes sense. So that's going to be our little error checking routine. And now that we have done our error checking, now we're going to go down, and what we want is we want this heat index. Okay, we want to measure the heat index. So what I'm going to want is I'm going to want to float, and I want to get this heat index in F. And because we know that we're going to be doing it, let's go ahead and do a float of heat index in C. And let's get those two numbers like that. And that looks pretty good. Let's come back down here. And then after we have done all of this, since I'm going to be printing them out, let's move this. So I've got the close. I'm getting this bracket that is the close of the if statement and the if statement. And let's cut. And let's actually do it right after I make the measurements. Okay. So right after I make the measurement, I will break. Okay. Now I am ready to find the heat index in C. And that is going to be DHT.compute heat index, and then what I pass it, temp C, okay, and then I also pass it the humidity. All right, now I also want the heat index in Fahrenheit. That's going to be equal to DHT.compute heat index like that. And what I'm going to pass it, temp F and humidity like that. Okay, so now I have those two heat indexes. Well, what do I want to do? Now I'm going to print those two things out. Okay, so what I'm going to do is I've got the humidity, and now I don't want to end it there. So what I'm going to do is I'm going to serial.print, and what am I going to print? I am going to print heat index colon space, and then what am I going to do? I'm going to serial.print, and I want to put it the same order before. I started with temp C, so I'll print temp C first. So I'll put heat index C like that, and then I will do a serial.print, and then what am I going to print? I'm going to print a space degrees C like that. Okay, and then I'm going to serial.print, and I'm going to print this time heat index F, that's in Fahrenheit, and then the colon, and then a serial.print, and then a space degree space F space like that. That is some crazy fast coding. Looks like I've got all my semicolons in there. So let's run it and see what happens. Okay, let's see what happens on this crazy code when we run it. What doesn't like float? Oh, did you guys see that? A flout. Flout is not an Arduino variable type. Float is. So let's try it again. See what happens. Man, I need to adjust this. This jumped over. Still not happy. DHT was not declared. Yeah. Remember we had that conversation. My DHT. Hopefully you guys saw that. I went back to my old ways, what I'd originally named it. But we are in the land of my DHT for our object. I think it's going to run this time. I really do. Looking good. Looking good. Okay. Come over here to the serial monitor. Let's see if we get some action happening. All right, let's look at this. Temperature is 28.9 degrees C. And why did this... It didn't go, oh, did I not ever do a print line? Oh, it's going off to the races to the right because I didn't do what? I didn't put a print ln in. You've always got to have your last one do a print ln. So that scared me for a second because I thought that it'd run once and then crashed, but it hadn't crashed. It was just printing out to the side. So that's okay. That's okay. Okay, there we go. So do you see, look, we've got temperature 28.9 degrees C, 84.02 degrees F. The humidity is 72%. That's a little bit kind of a high. And then you see I have the percent for relative humidity. Then the heat index is 24.87 degrees C and 91.18 degrees F. So somehow at 24.87, that does not make sense. So I think that I somehow here, I've got to tell it when I do that heat index, I've got to tell it, yeah. Okay. Do you see that 24 is less than 28? And so what did I do wrong? Okay. when I did the heat index, okay, what I should do is I should tell it, comma, true, that I am working in Fahrenheit, and then I should put comma, false, telling it that I am working in centigrade. I think I have that right. Yeah, HIC is false. All right. So you see, you've got to kind of tell it what you're working in so it can do the conversion correctly. So let's try that again. That one scared me a little bit too. The other thing is I want to put a space after the percentage so it's not right up against the heat index. So I'm gonna start over. Okay. We're doing pretty well. We're doing pretty well. Okay, so now let's look at, I need a space after the C too. All right, getting a little sloppy with my formatting there. I'm getting a little bit of a hurry, and that's why I'm being a little careless, because I want to show you one other thing before I give you the homework. Okay, let's take a look now. Okay, this is looking good. Temperature is 28.9 degrees C, 84 degrees F. The humidity is 72%. The heat index is 32.88 degrees C and 91.18 degrees F. So even though it is 84, it feels like 91. Now, actually, it's very comfortable here because I just wear short sleeve shirts and shorts, and we don't have any type of air conditioner, and this is like as hot of a day as what we're ever going to see, and it is just perfectly comfortable. Also have a cool breeze that's coming off the river, and so it's very, very comfortable here, and you can see that I very much have all the information, all the data I could ever want related to the temperature or the humidity. Okay, but what I want to show you is I really don't like doing all these print, and then print line. I want to show you kind of a different way that you can do this. I want to show you a different way you can do this. So all this, I'm going to just stop that. What was that? Let's see if I have an undo. I drug something. What I want to do is I want to just comment out all of these things. And let me start down here at the bottom. I'm going to comment out all of these prints that we just worked so hard on. And I'm going to come up and say edit and then say comment, uncomment. It makes all of those a comment. Now what I want to do is I want to build a string. So I'm going to create a new string that is called message. Okay, now I want to build that whole thing and then I want to print it. Okay, so what am I going to do after I've made all my measurements? I'm just going to build it all together. So message is going to be equal to, well, what do I have? I have a quote, and I want to say TEMP colon space, like that. Now you can string strings together, you can stack strings together with the concatenation. So A concatenated with B would be AB. Paul concatenated with McQuarter would be Paul McQuarter. And for a string, the concatenation is the addition sign, and it will just stack those things up. So let's say I'm going to add to that, concatenate to that, I should say, what? Temp C. And when I do that, it should C to make it a string, but let's do that. I don't think I have to convert it. I think it'll concatenate it, but let's just try that. Let's see what happens. Serial dot println and then message. Let's see if that works. And if it doesn't, I'll have to convert temp C to a string, but let's just see if I can just concatenate it that way. See, ooh, what happens. No, it didn't like it. It did not like that. So I need to convert temp C, which is a float. I need to convert that to a string. And the way I would do that is I would just give the command the string of temp C like that. And now I'll just print message. Let's see if that works. I'm glad I tested it before I made that huge long string. Okay, let's come to our serial monitor. Okay, you see, I'm printing one string that's going to be the whole thing. So now I can continue to build that string. So what would I say? I would concatenate that with the plus sign with what? With the string space DEG space C space, like that. Now I'm going to concatenate that with what? The string value of temp F, okay? And I'm going to concatenate that with the string space DEG space F, okay? Do you see what I'm doing? I'm just kind of going down here like this. And then I can go ahead and I know the next thing that it's going to want is humidity, like that, colon space. And now I'm going to come past the quotes. And now I'm going to add to that. What am I going to add? What comes after that? Let's come over here and look. Okay, now that is going to be humidity and then the percentage. Okay, so I'm going to add to that the string of the float humidity, and then I'm going to concatenate to that space percent space. All right, let's run this thing before we get it too long. Let's see if it's working so far. But you see, I don't put quotes around string because string of humidity, that's already a string. But the text percent, I put the quotes around. So hopefully this makes what I'm saying. Hey, look at that. That's working pretty good, 72%. And so now what I need to do is I just need to come in and I need to add the heat index. Okay, so now I'm going to, and I can just add that to the end of this string, which is going to be heat index, colon, space, and then come outside the quotes, and then I concatenate with heat index C, but that has to be changed to a string, like that, heat index C, okay? And then I need to concatenate with that the string space degrees C space, and then I need to concatenate that with the string value of heat index F, and then I need to concatenate that with space DEG space F, and then end the whole sentence with a period, close the string, and then our friend Mr. Semicolon. So let's try that and see what happens. Okay, let's try that and see what happens. Now, let's see. Look at that. Temp 28.9 degrees C, 84.02 degrees F, humidity 72%, heat index 32.88 degrees C, 91.18 degrees F. Yes, yes, that worked. Okay, now guys, don't hate me for doing this, because this is something you're going to need to know how to do, because sometimes you can't make things just by printing, print lining, printing, print lining. Sometimes you actually need to build the string and then just do something with that string. So I probably would not have taught you what I just taught you if you were not going to need it at some point in the future. So make sure that you can do it the brute force way like this, but then make sure that you know how to build a long string and then do it. So I just want to remind you, if you're just putting text, it's got to be inside of a quote. But like if you have a number that is a float, you have to convert that number to a string and then you concatenate that. Okay, does that sound good? All right, guys, I hope you're enjoying this. I want to show you what your homework assignment is going to be. I want to show you what your homework assignment is going to be. And what I want you to do is I want you to add a push button to your circuit board, and then this is what I want, okay? That if you come in and you push the button, let me see here, if you come in and push the button, then I want you to scroll the information across the screen. Humidity, 72%. The temperature is 84 F and 28 C. And the heat index is 91 F and 30 C. Okay? You see, when you press the button, I want you to scroll across here. Now you see I haven't put the button, I'm just scrolling. But what if you had a button? You could put this in a little box somewhere. You could put it in a little box somewhere. And if you want to know what the weather is, you would just come, you would press the button, and then it would scroll across the Arduino the information for you. Now this is starting to get kind of cool, right? We're at lesson number 31, but we're starting to get some pretty cool stuff. Okay, that's your homework assignment. Guys, please continue to post your homework assignment to YouTube, but please stop posting it as a short, because when you post it as a short, I can't back up and see something, or I can't skip ahead and I can't leave a comment. Just upload it as a YouTube video. Do not make it a short, because you're making my life kind of difficult looking at those shorts. I'm not saying that the video needs to be long in duration, but I'm saying make it a standard. Just upload it as a video to YouTube. Then in your video description, link back to this video, my video, and then in the comments down below, I want you to leave a comment that points me over to your homework solution, and I will run over there and take a look at it. Guys, I hope you are having as much fun taking these lessons as I am making them. I want to give a big thank you to you guys who are standing with me on Patreon. It is your encouragement and your support that keeps this class going, that keeps these new lessons coming. I want to thank you. You can also help me by leaving me a thumbs up or a comment down in the comments below. Also, make sure you subscribe to the channel, and when you do, ring that bell so you'll get notifications of future lessons. And as always, share this video with other people, because the world needs more people thinking like an engineer and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.